Okay, in this video I want to practice actually graphing a rational function. So we're going to put together all the things we've seen up until now. So we've talked about x-intercepts and y-intercepts. We've talked about vertical asymptotes, horizontal asymptotes, slant asymptotes. We've done sign tests before. I want to try and do it all for a particular function. So my function, I'm giving it to you both in factored and not factored form. I'm pointing to the wrong ones. But numerator x squared minus 3x, which you can factor as x times x minus 3. Denominator x cubed minus 3x squared plus 4, which is the same as x plus 1 times the quantity x minus 2 squared. So let's just think our way through what each of these is. I'm actually going to do my vertical asymptotes before I do my x-intercepts. So vertical asymptotes, we said, means the denominator equals 0. And the denominator is 0 when x is negative 1 and x is positive 2. So hopefully everybody can just see that. So we're going to have two vertical asymptotes. So why don't I already just start with drawing a picture, and as I figure out more and more information, I'll put it on the graph. So we have a vertical asymptote at x is minus 1, and another vertical asymptote at x is positive 2. Okay, next up I'm going to look at x-intercepts. So in order to find an x-intercept, I set y equal to 0 and solve for x. And I specifically did the vertical asymptotes first because if the denominator is 0, the left side isn't going to be equal to 0, right? If I'm trying to solve 0 equals x minus 3 over x plus 1, x minus 2 squared, if the denominator is 0, it's not going to be equal to 0, it's going to be undefined. And so the only time that this guy can be 0 is when the numerator is 0. And so this is a little different from what we're used to for polynomials. We just look at all the factors in order to tell what are the x-intercepts. But now, since we have both numerators and denominators, if the denominator was 0, our function would be undefined, it wouldn't be in the domain. That's not going to be an x-intercept. The only time we have x-intercepts is when the numerator is 0. And again, we should be able to just read this off from the factored version. X times x minus 3. If x times x minus 3 is equal to 0, then either x is 0 or x is 3. Okay. End behavior means looking at the degrees of the top and bottom to figure out if it has horizontal or slant asymptotes. Okay, and this is why I gave it to you both in the factored form and the not factored form, because if I'm looking at the degrees, I would much rather be looking at this guy that's not factored. So I can see, okay, the power of x is an x squared on top and an x cubed on bottom. And so this is actually the case where the denominator wins. The denominator has a bigger degree. And so that means as I plug in larger and larger numbers for x, this is going to be a relatively small number divided by a relatively large number. And so it's going to end up going to 0. And so our horizontal asymptote is going to be y equals 0. I guess I should have labeled these. These guys are vertical asymptotes. Okay, so something else I didn't mention in the last video is it turns out the end behavior is, since it's just determined by the degrees, you're not going to be able to have two different horizontal asymptotes. So like, we'll never have a graph that has one horizontal asymptote on the right and a different horizontal asymptote on the left. A rational function can never do that. We also won't have a situation where there's a horizontal asymptote and a slant asymptote. Again, there might be functions that do that, but none of them are rational functions. Any rational function is going to have the same asymptote on the left and the right. So if it's got a slant, it's got a slant, period, end of story. It can't have two different ones. Okay, so these cannot happen for polynomials. I said I was going to write things down as we got them. I haven't really done a good job of that. X-intercepts at 0 and 3. So that is a point where we're hitting the x-axis. And that is at x is 0 and x is 3. We also have a horizontal asymptote, y equals 0. Y equals 0 would be the x-axis. So apparently the graph is getting closer and closer to the x-axis on the edges of the graph. Okay, anyway, next up is y-intercepts. In order to find the y-intercept, that should be singular. We're not going to have two different y-intercepts. If there were two y-intercepts, we would fail to be a function. So our y-intercept is just going to be plugging in x equals 0. And again, I can almost do this without writing anything down. If I stick in a 0, we have 0 and 0 and 0 and 0 and a 4. And so our horizontal asymptote is y equals 0 squared minus 3 times 0 divided by 0 cubed minus 3 times 0 squared plus 4. 0 divided by 4 is just 0. So our y-intercept is actually y equals 0, which is the same as our x-intercept. That's basically just saying we're hitting the origin. Okay, so don't confuse the horizontal asymptote of 0, which is this dotted line, with the y-intercept of 0, which is this dot, where x is 0 and y is 0. Okay, and the last thing I want to do is a sign test. I know my graph has to go and approach these dotted lines. It's got to go through these two dots, but that's about all I know. I would like to know, if I plug in a number like 4, 5, and 6, is the graph positive or is the graph negative? If I plug in a number between 2 and 3, is the graph positive or is the graph negative? So I'm basically trying to narrow down between these two possibilities. Both of these are going through the point at x equals 3. Both of these are approaching the vertical asymptote at x is 2. I don't know which one is the correct part of the graph. So in order to do that, I'm going to use a sign test, determine when the function is positive and negative, and it turns out we're going to use all of our x-intercepts and vertical asymptotes in our sign test. We ignore completely the horizontal asymptotes, the y-intercepts. Even if this had been like 7 and 2/3, I would ignore those numbers. They wouldn't be part of my sign test. I'm only going to use these numbers that are x-intercepts and vertical asymptotes. So I'm going to draw my little number line, and I'm splitting the number line up at -1, 0, 2, and 3. So I'm not drawing this to scale. I just want to have some room to work. Okay, so I start off by picking a number in each interval. I'll pick x equals 4, plug it into the function and see if it's positive or negative. So I'll plug it into the factored form. We have 4 times 4 minus 3 divided by 4 plus 1 and 4 minus 2 squared. That's a positive and a positive and a positive and a positive squared. If I multiply and divide a whole bunch of positives, I'm going to end up with a positive. So on my far right side, numbers right of 3, I'm getting positives. Okay, numbers between 2 and 3, I would pick my favorite number, maybe plug in x equals 2.5. And just check each of these guys, is it positive or negative? Okay, so let's try and do it without writing down all the numbers. If I stick in 2.5 for x, that's a positive. 2.5 minus 3 is actually going to be a negative. 2.5 plus 1 is 3.5, that's positive. And 2.5 minus 2 is 0.5. Which is positive, and we're also squaring it. And so notice we only have one negative sign, which means we are negative. So numbers between 2 and 3, we're getting negatives. And so I guess I can rule out this. The graph has to be below the x-axis between 2 and 3, so I guess the graph would look like this, approaching the vertical asymptote. I'm going to condense my life from here. Rather than plugging in a number between 0 and 2 and a number between 0 and -1 and so on, I'm going to use the multiplicities, like we talked about in the polynomial section. So from 4 to 2.5, we went from one side of 3 to the other side of 3. And 3 corresponds to x minus 3, which has multiplicity 1. Multiplicity 1 means you're going to change signs. Going from one side of 2 to the other side of 2, this guy is going to change signs, but because of the square, we're actually changing signs twice. And so if I'm negative and then I flip signs twice, I'm back to negative. If you don't trust me, that's okay. Just plug in x equals 1. You should end up with a negative. Okay, let's see. 0 is coming from this guy, this factor. It also has multiplicity 1, and so we're going to flip signs once when I go from one side of 0 to the other side. Again, you can plug in your favorite number between 0 and -1. You should end up with a positive. And then left of -1, let's see, -1 corresponds to this guy, which is multiplicity 1. And so multiplicity 1 means we're going to flip signs. Okay, so putting all that on the graph. Left of -1, we're negative. Between -1 and 0, we're positive. Between 0 and 2, we're negative. Between 2 and 3, we're negative. Right of 3, we're positive. So what ends up happening is we've put so much information into this graph that we know when the graph is going to be above and below the x-axis, and we know what happens on both the left side and the right side of every single interval. So for instance, the interval from 3 to infinity, on the right side, it has to be approaching its asymptote. On the left side, it has to be touching this dot. Okay, so if it's approaching its asymptote and going through this dot, and it's positive in between, there's not a lot of options. It's got to look something like that. It goes through a dot and gets closer and closer to the asymptote. Between 2 and 3, we already talked about. It has to approach its vertical asymptote. It has to go through this dot. Not a lot of options there. It looks like from the dot, we're going down. Numbers between 0 and 2. The left side has a dot. The right side has a vertical asymptote. We're negative in between, so that tells me I'm going down, not up. And so I must be looking something like this. Numbers between -1 and 0 have to be giving us a positive value of the function. The left side has a vertical asymptote. The right side has a dot. So get close to the vertical asymptote, go through the dot. Should look something like that. Numbers from -infinity to -1. We said the graph is negative, so it should be down here somewhere. The left side has a horizontal asymptote, right side has a vertical asymptote. So we have to be approaching both of our asymptotes, something like that. So just go back and double check in each region, do we have the sign that we got from the sign test? If yes, good. Go back and double check all of our x-intercepts, vertical asymptotes, and y-intercepts and so on. Do we have the same shape that we said we were going to have? I have x-intercepts at 0 and 3, yep. I have vertical asymptotes at -1 and 2, yep. I have a horizontal asymptote at 0, yep. Y-intercept of 0, and this particular sign test, yeah, everything looks good. And then the last thing we should probably check is make sure it's a function. Like, it has to pass the vertical line test. If you have a vertical asymptote and you're doing something like this to it, this should be setting off warning bells in your mind because this is not passing the vertical line test. So just be really careful that you check your answer, make sure it satisfies all the things you said it was going to satisfy, and it still has to be a function. Okay.